What if aliens aren't sending radio signals, but instead rewriting the chemistry of their own star by using nuclear energy? Humanity witnessed the cruelty and destruction of nuclear war on August 6, 1945, when the USA detonated the first atomic bomb over the city of Hiroshima. Only 3 days later, a second atomic bomb was detonated over Nagasaki. Between 150,000 and 246,000 people were killed, most of them civilians. These bombings marked the end of World War II and remained the only use of nuclear weapons in an armed conflict. On April 26, 1986, an explosion occurred at the Chernobyl nuclear power plant in what was then the Soviet Union. The Chernobyl disaster, along with the Fukushima nuclear accident in 2011, remains one of only 2 nuclear energy accidents ever classified as the maximum severity of the International Nuclear Event Scale. Hello, I'm Dr. Alejo. Despite these tragic events, nuclear energy is considered by many experts to be one of the cleanest and safest low-carbon energy sources available today. However, critics usually point to 2 major concerns. The first is the risk of catastrophic accidents, which history shows we must take seriously. This issue can be addressed, at least in principle, with better regulations, engineering standards, and oversight. In other words, politics. The second problem is far more technical: long-lived radioactive waste. Radioactive waste requires secure storage for thousands to millions of years, something humanity has never truly solved. And yes, some might argue that politics is still the hardest problem of all. But this raises an intriguing question. What if, instead of storing nuclear waste on a planet, we could use our star, the sun, as a disposal site? What if extraterrestrial civilizations are already doing exactly that? And what if I told you that some scientists believe they may have identified a star that could fit this scenario? In their 1966 book, Intelligent Life in the Universe, Carl Sagan and Iosif Shklovskii proposed an intriguing idea. They suggested that an advanced extraterrestrial civilization might deliberately add rare, easily detectable elements into the photosphere of their star as a way of announcing their presence to the universe. This idea is often referred to as star sorting. The concept is simple. Add something unusual enough that any civilization capable of spectral analysis, like ours, would notice. Then, in 1980, physicists Daniel Whitmire and David Wright published a paper titled Nuclear Waste Spectrum as Evidence of Technological Extraterrestrial Civilizations. They proposed that dumping radioactive waste into a star could serve a dual purpose, solving a long-term waste problem and unintentionally or deliberately creating a detectable technosignature. This process would leave behind a very specific spectral fingerprint dominated by elements produced when uranium and plutonium undergo nuclear fission. Whether intentional or accidental, such an imprint would qualify as a technosignature, which is defined as evidence of technology modifying its environment in a detectable way. The authors specifically suggested searching for elements like praseodymium and neodymium, rare earth elements that should normally be scarce but would become highly overabundant if nuclear waste were involved. They also highlighted elements with no long-lived stable isotopes, such as technetium and plutonium, as particularly strong indicators. Like many technosignature ideas, Dyson spheres, for example, star sorting began as a thought experiment. Interesting, but not something most researchers expected to observe anytime soon. That changed in 2007, when a detailed spectral analysis of a star called HD 101065, better known as Przybylski star, reignited the debate. The star was originally discovered in 1961 by Antoni Przybylski, a Polish-Australian astronomer working at Mount Stromlo Observatory here in Australia. I'm definitely butchering the pronunciation of this last name, so I apologize in advance. Now, Przybylski's star is classified as an AP star. That means it's an A-type main sequence star, with the P standing for chemically peculiar. A-type stars are main sequence stars. meaning they are still burning hydrogen in their cores. They typically have masses between 1.7 and 2.1 times that of the Sun, and surface temperatures between 7,600 and 10,000 Kelvin. Because they are more massive than the Sun, they live much shorter lives, roughly a quarter of the Sun's lifetime. Normal A-type stars usually have weak or negligible magnetic fields, which allows them to rotate rapidly, often faster than 100 kilometers per second. AP stars, on the other hand, exhibit strong global magnetic fields, which slow their rotation to below 50 kilometers per second and dramatically alter how elements behave in their atmospheres. In most stars, spectra are dominated by common elements like iron, calcium, and magnesium. But when astronomers analyzed the spectrum of Przybylski's star, they found extreme overabundances of rare elements such as praseodymium, neodymium, samarium, europium. These elements are normally present only in trace amounts, but in Przybylski's star, they dominate the spectrum. Even more puzzling, some studies have claimed spectral signatures consistent with elements that, on Earth, are primarily produced artificially, such as plutonium, neptunium, einsteinium, and berkelium, named after Pluto, Neptune, Einstein, and Berkeley. These elements are typically created in nuclear reactors or particle accelerators, and many have very short half-lives ranging from years to a few million years. For a star that can exist for billions of years, their apparent presence is deeply problematic. So, what's going on? One early hypothesis suggested that Przybylski's star might have a neutron star companion whose energetic radiation could trigger an unusual nuclear reaction in the star's atmosphere. However, observations show no evidence of a nearby neutron star, and this explanation has largely fallen out of favor. Another possibility involves the theoretical island of stability. Nuclear physicists predict that there may exist ultra-heavy nuclei with a special combination of protons and neutrons that make them far more stable than expected. If such isotopes exist, they could decay into elements that resemble the ones we think we are seeing, without requiring continuous replenishment. However, this idea remains theoretical, and no such long-lived super-heavy elements have yet been confirmed. There is also a far more mundane explanation. The strong magnetic fields of AP stars split and distort spectral lines through a process known as the Zeeman effect, turning clean atomic signatures into tangled patterns. Identifying elements in such conditions is like trying to read a barcode that's been stretched and broken apart. So the simplest and more boring and perhaps most likely explanation is that some of these elements have been misidentified due to incomplete atomic data and complex magnetic effects. And then, of course, there is the fun possibility and the reason of why we are talking about this star in this channel. Przybylski's star could represent a technosignature as envisioned by Sagan and Shklovskii in 1966 and expanded upon by Whitmire and Wright in 1980. To be honest, this explanation is unlikely, but that doesn't mean it isn't worth exploring. As discussed in my video on the Kardashev scale, a civilization capable of salting its star will likely be a Type II civilization, able to harness the full energy output of its parent star and undertake massive astro-engineering projects. Such a civilization could be disposing of nuclear waste or deliberately signaling its presence to the universe. That said, Przybylski's star is estimated to be about 1.5 billion years old, less than half the age of Earth, unless intelligent life emerged unusually early on a planet orbiting this star. The existence of an ancient technological civilization there seems unlikely. So, is Przybylski's star evidence of aliens or simply a misinterpretation of complex data? We don't know yet, but if these elemental detections are confirmed, they could revolutionize our understanding of nuclear physics, chemistry, and stellar evolution, even without invoking extraterrestrial intelligence. Let's hope more astronomers turn their attention to this remarkable star, because regardless of the explanation, Something very strange is happening there. If you enjoyed this video, don't forget to like, subscribe, and press the bell icon so you don't miss future uploads. I also invite you to check out my video on METI, Messaging Extraterrestrial Civilizations, where we explore the pros and cons of letting the universe know about our presence. Salting our sun could one day be a way for us in the far distant future to signal other civilizations that we exist. This is the last episode of 2025. Thank you to all of you that have joined me in this journey so far. A journey we started this year to pursue our passion of discussing the possibility of extraterrestrial civilizations. Also, if you are struggling to find a good Christmas present for a loved one or even for yourself, I recommend you to check out my book, A Story of More Than 5,000 Worlds, where we explore technosignatures and many other SETI-related ideas, in addition to star and planet formation, exoplanets, and many other exciting astronomy topics. That's it for now. We will return in 2026. And remember, the truth is out there.